Hello all, welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. Today we are going to see working of a solar planet. So we were in the first module where we are studying the different sources of energy. There are conventional sources of energy and non-conventional sources of energy, where this solar energy comes into non-conventional energy, which is renewable. So even after using the energy from the solar radiation, we can still use it for many more years. So in this topic, we are going to see, first of all, we should know what is solar energy and how the solar energy is being generated. You can see in this slide, the sun is the star at the center of the solar system, where it is nearly a perfect ball of hot plasma heated to incandescence by nuclear fusion reactions. So you can see in this picture, sun is like a giant ball of fire where it can emit radiation by the chemical reactions inside the core. The main elements which are being burned in order to generate this energy are helium and hydrogen. This enormous amount of energy will be radiated in the form of light, ultraviolet radiation, and infrared radiation. So, the radiation coming from the sun, which is the nearest star to our solar system, this is the main source of energy on all the planets. Especially for Earth, the main source of energy is sun. Most of the energy that is gained, the living organisms on Earth are livable because of the energy that is given by the sun. So without sun, we are not possible to inhabit this planet. And one more important thing is, we are in the Goldilocks zone. That means we can see we are orbiting around a star, which we named it as sun. We are in a perfect distance from its surface. We are not too far, which makes us very cold, just like Pluto. We are not too near, which makes us burn, just like on the surface of Mercury. So we are in the special zone where we get enough heat and we have a covered atmosphere where it will filter the ultraviolet radiations, where we call it this filter layer as ozone layer. And because of this entire system, the planet Earth is very inhabitable for living organisms, not only human beings, plants, animals, microorganisms, etc. So the surface of the sun radiates the energy in the form of light, which is the key source of working on the planet Earth. Not only on the planet Earth, we can use this light source that is being emitted from the sun on all the different planets. When we want to go to Mars, there is a planet called Mars, which is very near to Earth. If we want to go there, we should use the energy that is being generated by the solar radiation. If I want to launch a satellite and if I want to make the satellite to work for like many years, like 10 to 15 years, I have to use the solar radiation and I have to generate the power coming from the solar radiation using solar panels. And this energy will be stored in the batteries and it can be used to run the entire satellite for communication purpose. Now, this is all about solar energy, where we are orbiting around a star, which is an average star, because there are many other stars in the universe which are better than the solar sun. Okay, now this energy coming out of the sun is being utilized by the earth in different forms. So the key source of life on earth is solar energy. Now, We'll see what is the definition of a solar power plant. The main topic of today is solar power plants. Now we'll see what is a solar power plant. In this picture, we can see we have installed a large number of solar panels. They are photovoltaic panels. They can absorb the solar radiation and they can convert this solar radiation into electrical energy. Now, converting entire this thing is completely related to electrical engineering. Now, we will discuss only how the source of solar energy is converted into electrical energy. We have a photovoltaic cell. This photovoltaic cell is very sensitive to solar radiation. When the solar radiation falls on the plate, the photovoltaic cell will react and it will produce some electrons which are taken into the power line. Okay, so that is how the electricity is generated. A solar power plant is a facility that converts solar radiation made up of light, heat, and ultraviolet radiation. So these three things, light, heat, and ultraviolet radiations, are completely converted into electricity, and they can be supplied to homes and industries. Now in this picture we can see this is a solar power plant where a vast number of solar panels are being installed in the open surface where the light will be impelled on the solar panels, where all these solar panels are connected to a central controlling system where they can collect the solar energy in the form of electrical energy and they can be used later. The main disadvantage of solar energy and collecting the solar energy is we can store the solar energy up to a certain quantity and after that we cannot store. So the solar energy which is converted into electrical energy should be utilized as early as possible. Okay, now we'll go to the next slide. Now we'll see what is the history of a solar power plant. See, in the year 1860s, the first solar panels were developed. So the first solar panels were developed by two scientists called Augustin Mocout and Charles Fritz. These are the names of two scientists from America where they have developed the solar panels. They know that someday the coal will be exhausted and this coal has to be replaced by some other kind of energy. So that is why they have started thinking of new form of or new source of energy. They thought solar radiation is very useful and the solar radiation can be directly converted into electricity. This is the first time where the invention of solar panels was done. In the year 1884, probably after 24 years of research, they have developed the solar panels which were installed in New York City. And these solar panels has the efficiency of about 1%. Only 1% efficiency is there for the solar panels that was developed back in the year 1884. So they were first installed in the city of New York. And nowadays, the current efficiency or the maximum efficiency of any solar planet on the earth is about 50%. Any solar panel installed to convert solar energy into electrical energy can convert only 50% of the solar radiation into electricity, not more than 50%. The maximum efficiency of any solar plant is only 50%. So, what happens to the remaining 50%? Most of the solar radiation is emitted in the form of heat. It is lost in the atmosphere. It is somehow not grasped by the solar panels. That is why the maximum efficiency that can be attained by any solar panel is about 50%. In fact, most of the solar panels have the efficiency less than 20%, not more than 20%. It has only very small efficiency like 15 to 20%, which is very small when compared to a thermal power plant or a hydraulic power plant, where we can get 70 to 80% of efficiency. Now we'll go to the next slide. Importance of solar power plants. So why these solar power plants are very important? There are some important things where the solar energy can be used or there are some places where we cannot bring our conventional forms of energy like petrol, diesel, or coal. We cannot carry this fuel to places like space, where we are going to do a lot of experiments in the outer space. In this picture, we can see the International Space Station, which is built in collaboration with the different countries like USA, China, Russia, and European Space Agency. All these people unitedly built this laboratory, which is very big when compared to, we can compare like it is of the size of a 400 football stadiums. Like, you can imagine, this is very big. Each and every function of the laboratory are supported by solar energy itself. There is no alternate power source on this lab. We have to use solar energy, and for this we should install some solar panels on the lab, so that it will collect the solar energy and it will directly convert that into electrical energy. And one important thing we should keep in mind while designing the solar panels for a satellite: there are two types of satellites which can be used on the Earth, which can be used in the outer space. So the conditions outside the atmosphere are very different outside the Earth's atmosphere. In outer space, the ultraviolet radiation is very high. The heat or the incoming solar radiation is very high when compared to the surface of the Earth, because we have the ozone layer which filters most of the ultraviolet and infrared radiations, and it will convert this ultraviolet radiation into normal visible light. Whereas in outer space, we can get more intense, more heavy radiations from the solar energy, which can be converted into electricity more efficiently, because there is no atmosphere, there is no space or a medium in the outer space where the energy is being lost. So the solar energy is the one which does not require any medium. Solar energy does not require any medium. When we study the subject of heat and mass transfer, where we will study the heat is being transferred from one place to another place, or from one object to another object, where we will transfer the heat from one place to another place by using a medium. We will use different mediums like solid phase, liquid phase, or gaseous phase. So some kind of medium is required in order to transport the heat from one place to another place, or from one part of the body to another part of the body. But this solar radiation, which is a combination of ultraviolet rays and infrared radiation, it does not require any medium. Even in the outer space, there is no air or any kind of medium. The solar radiation coming from the sun will reaches the surface of the earth. So solar radiation is the one which does not require any medium. Now we'll see what are the different points or different applications where we can use the solar energy or solar panels. So because of the renewable energy, we can use solar panels or solar power plant for production of electricity. Back in the year 1800, the solar power plants were very small. They were installed like for working of a small electric bulb. Only one or two solar panels were available in that time, back in the year 1860. Nowadays, most of the street lights are being installed with solar panels, where we will get unlimited power which is being generated from the solar radiation, and they can be used to light the bulbs during night time. Now, this is a renewable energy. As long as we can use, we can consume large amount of solar energy, but still it is being developed or generated by the solar activity for next 400 million years. Okay. And next point is non-maintenance. So the solar power plant or the solar panels requires very small amount of maintenance and cleaning. Okay. So when compared to other power plants like thermal power plant or hydraulic power plant, they require large amount of maintenance, because they are large amount of moving parts where they require continuous maintenance, lubrication. They need to be scaled. The scales which formed in the hydraulic turbines has to be removed. The thermal power plants, coal will create some kind of black color ash on the surface of the chimneys. So all these things has to be cleaned. So in solar power plants, there is no need for them. We should keep the solar power panels as clean as possible in order to grasp the solar energy. That is the only maintenance we have to do in the case of solar power plants. And next third point is not dependent on other sources of energy. So this is not a dependent source of energy. The solar energy itself is a independent source of energy where it is being generated by the sun, and this energy is directly converted into electrical energy. Where in the case of a thermal power plant, where we have to first we have to take the coal, we have to burn this coal, and the heat emitted from this coal is used to boil the water. Now the water after boiling will be converted into steam. This steam will be fed on the turbines. So this is a long procedure where a lot of efficiency is lost, and there are different stages. Coal is not the energy that is being generated from the coal is not directly converted into electrical energy. First, it is converted into heat energy. This heat energy is converted into boiling of the water. Water will be converted into steam. The high pressure of the steam will be converted into mechanical energy of the turbine, and this mechanical energy of the turbine is again converted into electrical energy with the help of a generator. So this is a very long process where the conversion of energy from coal to electrical is very time taking. So this is completely a independent source of energy where the incoming solar radiation directly converted into electrical energy with the help of solar panels. And then solar energy is clean and green energy. Okay. Now the solar energy is clean and green energy because we are not creating any carbon footprints. We are not creating any kind of carbon emitted from this solar panels. We are not creating any kind of scaling formation on the turbine parts. Okay. Now we are just creating some solar panels, and these solar panels are placed on the surface where we can get more solar radiation, and this solar radiation is absorbed and it is converted into electrical energy. Now this is one thing where the power plants are very important. Maximum usage. If I installed a power plant which is of very large capacity, I can use the entire energy generated by this solar power plant. Now, because of the maximum usage, I can use the solar power plant very efficiently. Next, technology development. So, there are different points where the different aspects of technology, directly or indirectly dependent on the solar radiation or solar energy, where they can be working. The best example for this is the satellites, where the only source we can carry with the satellites is solar panels. We can use them for longer periods because if I carry a battery instead of solar panels, after some time after some time the batteries may run out and the satellite may not work. So if I have solar panels, so the solar panels will continuously take the energy from the sun, and this can be converted into electrical energy continuously. So because of this advancement or because of this non-availability of heavy conventional resources in some places, we have to go for solar radiation. So this is the importance of solar power plant. Next we will go to types of solar power plants. So in this slide we can see there are three types of solar power plants. First thing is photovoltaic solar power plants, where in this picture we can see we will install some solar power plants which are connected with the help of electrical wires, and these are connected to batteries or they can be directly fed into electrical grid. Now this is the first kind of solar power plants where we will use some kind of photovoltaic plates. These plates, when they are subjected to solar radiation, they will create some reaction, and they will convert the solar radiation into electrons. The flow of electrons will in turn be converted into electricity. So the flow of electrons itself can be called as the electricity, and this is how the first kind of photovoltaic cells, they can be converted into electrical energy. Now we have second kind, concentrated solar power plants. So these are another type of solar power plants where we have large number of mirrors. All these mirrors are aligned towards the sun at different times in a day, because as we are living on the planet Earth, we will be continuously rotating around the sun in a span of 24 hours. Out of this 24 hours, only about 12 hours we will get the solar radiation on a particular surface on the planet Earth. So we have to use this 12 hours of duration efficiently in order to catch the solar radiation which is coming from the sun. So in this picture we can see we have large number of mirrors. These are photosensitive mirrors. These mirrors are aligned in such a way that always the radiation coming from the sun will be concentrated and they will be focused at a single point on the top of a long tower. In this picture, in the center, we can see there is a tower on which we have photosensitive element. Now, whatever the radiation that is falling on these mirrors will be reflected directly to the center of this tower, where the energy will be converted into electrical energy. The solar is converted into electrical energy. So this is another kind of solar power plant where it is called concentrated solar power plant, because all the mirrors which are being used to concentrate the solar radiation into a single point where it can be converted and into electricity. And third type is hybrid solar power plants. In hybrid solar power plants, it is a combination of both photovoltaic and this concentrated solar power plants, where we will combinedly use these two. That means the solar panels itself, they will act as mirrors. They will absorb some energy, and at the same time, they will concentrate the solar radiation to the top of the tower. So it is the combination of first two types. So photovoltaic cells itself act as the solar mirrors. Now we'll go to next topic, components of solar power plant. So there are different components of solar power plants where we have to study all of this in detail. Now, the first component of the solar power plant is solar panels. As we have seen many pictures of the solar power plant, in this picture we have seen. So, the main component of any solar power plant is solar panels. First of all, we should have some solar panels, and then we should have some inverter where this energy, the solar energy, is being converted into electrical energy. This electrical energy should be efficiently collected and it has to be stored in the batteries. So there are three main components of any solar power plant. First thing is solar panels, second thing is inverters, and third thing is batteries. So these are the three main components of any solar system, where in this picture we can see a person installing the solar panels. So let us see some advantages of solar panels. So why do we use solar panels, or why do we go for a clean, renewable, non-conventional source of energy? I have said three things: clean energy, renewable energy, and non-conventional source of energy. So why should we go for solar power plants when we have other sources of energy? The first and foremost thing is that it is renewable. Even though if we use the solar radiation for the next coming 400 million years, still we have enough solar radiation that is coming from the sun for the generation of electricity. So this is not at all exhausted for the next 400 million years, because the star, the sun, it will not be burned out, not in the near time. It will take like 400 million years for the sun to be exhausted. Okay. and then cost effective. I know the solar panels are little costly than normal things. The solar panels are little costly when compared to other things like uh, thermal power plants and other things. But the solar power plant is very cost effective when compared to once the solar panels are installed, we can use them for longer periods. We can use them not only for years, we can use them for decades until they are properly maintained. Now, these are cost effective because they require less maintenance and they don't require continuous uh, like maintenance, repairs. These are not there. Once the solar panels are fixed, they can be used for multiple times. Now we'll see in the next advantage is low maintenance. So very low maintenance is required for solar panels because they can be easily cleaned. Only the problem is dust. If the dust on the solar panels is more, they cannot take the solar energy. So that is why the solar panels has to be cleaned just for the dust, removal of dust. So very low maintenance is required in order to uh, make the power plant work. Now there are some challenges of solar power plants where we have to overcome these challenges in order to make the solar panels or the solar power plant to get more efficient electricity generation. Now we can see here the first thing is weather dependence. Depending on the weather, the solar energy generation will be modified or it will completely depend on the weather condition. If the day is very hot and it is very sunny, the development or the generation of solar energy is more when compared to a day when it is raining or the day when it is in the winter when it is snowy. You can see in this picture the solar panels are covered with a thick layer of snow where they have to be cleaned properly every day because the rainfall or the snowfall is very high in some places of the earth where we have to continuously remove the snow so that the solar panels will be faced directly to the solar radiation. Otherwise, we cannot use these solar panels for generating the electricity. They are completely covered in snow. And then intermittency of solar energy. Sometimes, because we are living on the planet Earth, we have an atmosphere. This atmosphere is directly or indirectly, it will maintain or moderate the incoming solar radiation. This solar radiation is, however, should be taken into matter. The atmosphere should be taken into matter while we calculate the amount of electricity generation while we are installing a power plant. Because what happens when I have installed a solar power plant at a place where the solar radiation is very low when compared to other place, like in deserts, the solar radiation is very high when compared to an area where there is a large forest. So that is why I should choose a place where solar radiation is more, or very high altitude places are chosen, or very hot places like deserts are chosen, where there is no rainfall, there is no formation of clouds, so there is nothing that can stop the solar radiation from falling on these solar panels. So, depending on this condition, we have to choose a perfect area for installing the solar panels. So, that is intermittency of the solar energy. And then third one is land usage. Solar panels needs a large amount of land. They require large land in order to install them. So if I want to produce a amount of electricity which is equal to a thermal power plant. Suppose I have a thermal power plant and I have a solar power plant. Suppose if I want to produce same amount of electricity from these two power plants, like 10 kilowatt hours. Here also I have to produce 10 kilowatt hours of electricity. Now, when we compare the land that is taken or occupied by this thermal power plant is around 1 acre. So the thermal power plant will take 1 acre of land for its installation. Now, similarly, if I want to use a solar power plant for the production of a 10 kilowatt hours of power, I may require 10 acres of land. Even though after taking 10 acres of land for installing the solar power plant, we will get only 50% of the efficiency. I may not be producing 10 kilowatts of power because more the energy requirement, more the area to be covered with solar panels. So that is why the land usage is very a tough problem that is being faced by any solar power plant installation. So mostly in a densely populated countries like India or China, where we have very large population living in a very small area, we don't have enough place to install a solar power plant which is large enough to produce electricity as equal as a thermal power plant. Suppose I have to use a solar power plant instead of a thermal power plant. I need a large area, very large area, which is more than 10 times the area taken by a thermal power plant. So, which is not possible in a very small country like India. This is like we can take some other countries where they have huge country, very low population is there. There we can install this solar panels and they can be used efficiently because most of the land, like we take the example of Australia or USA or Canada, Russia. So all these countries have a large amount of vast barren lands which can be covered with the help of the solar panels, and the solar panels will generate electricity without having any maintenance. So this is one problem in small countries like India, Japan. China is not a small country. Next, we'll see what are the challenges of solar power plants. So the first challenge is site selection, where we have to select a site. Depending on the site where we have to install the power plant, we should choose cleverly. The site should be chosen cleverly because when we want to generate power, that is electricity from the solar energy, this energy has to be generated more efficiently. In order to generate more efficient energy, we have to choose a site which is very near to a desert or a place where very high altitude, or it should be a place where there will be no clouds. No clouds means no rain. So we have to choose a place like this. Like if the place is in a desert, there will be very less rainfall, and so that we can get maximum solar radiation during the daytime. Eventually, in the night time, we cannot get any solar radiation. We cannot change that. At a place where very high altitude is there also we can get large amount of solar radiation, and we should choose a place where there are no clouds or very less rainfall, where we can get very less rainfall with no clouds at all. And second thing is system sizing. Depending on the availability of the site or depending on the availability of the land in a particular area where we can get maximum solar radiation, depending on that, we should design the solar power plant size. So, power plant, more solar panels will produce more electricity when compared to a solar plant with less number of the solar panels. More the area covered, more the electricity produced. And then construction and installation. So, we should not choose a place where there is no transportation is possible. There should be a road transport available or train transport, and the equipment, the solar panels or the solar batteries, etc., they have to be easily carried to a place where we have selected as a site for the installation. So the site construction and installation should be very easy. So in order to do this thing very easy, we should choose a place where we have very good transportation facility. Okay, so these are some of the challenges that are faced while installing a solar power plant. And then we'll go to the operations and maintenance of solar power plants. So, what are the points required for operation and maintenance of solar power plants? So, the solar power plant requires a routine maintenance. Like the solar power plants are placed in the open land area where they may be subjected to dust, or if the atmosphere is very prone to rainfall, they may get wet. If the atmosphere is very uh, like snowfall can be happened. So all these things can be keep in mind while installing a solar power plant. So the routine maintenance includes cleaning of the surface of the solar power plants, checking the cables. The electrical cables has to be checked for good condition or not, because we are placing this entire thing in an open area. And then second thing is performance monitoring. We have to check whether all the solar panels are working fine and they are generating perfectly. They are generating the solar energy into electrical energy in a perfect manner. They should be efficient as new as possible. Okay. So the performance of each and every solar panel has to be checked periodically in order to make the power plant more efficient. And then troubleshooting and repairs. So whenever a failure has happened in a solar plant, it has to be troubleshooted previously. We should not wait for a damage to be happened. We should continuously monitor the working of each and every part of the solar power plant. And the troubleshooting or repairs should be done before, not after the damage or failure. We have to do the repairs before itself. So the maintenance and troubleshooting should be perfectly done in order to get maximum efficiency from a solar power plant. So these are the operations and maintenance of a solar power plants where we have to do continuously and regularly. So we'll see what is the future of a solar power plant, where we can use this solar energy or the solar power plants in future. First thing is technological advancement, like space exploration. If we want to build a large laboratory on the surface of planet Mars, we have to use this solar energy. We cannot carry large amount of energy source, like we cannot carry coal or anything onto the surface of Mars by using a rocket, because it takes itself a large amount of fuel for lifting a rocket from the surface of the Earth. We have to reduce the usage of we have to reduce the weight of the rocket in order to lift it easily, because every inch or every kilogram of weight we kept on the rocket will require an equal amount of fuel. So that is why if we want to decrease the amount of fuel being carried into the outer space or to other planets, so there we have to use this solar panels, which will have some weight, but they can be reused. If I carry coal into outer space, I require oxygen for burning the coal. But the solar energy is readily available in any planet on the solar system, not only in our solar system, in the universe. If we go to any planet where it is orbiting near a star, we can collect that solar radiation and they can be converted into electrical energy instantly. So, due to this technological advancement, the future of solar panels is very vast. Role in energy transition. So, because we see the conventional energy sources on Earth are being depleted, are being decreased day by day. They are being exhausted. So that is why we should move to more convenient or more resourceable renewable energy source where we can get maximum efficiency without giving large input. This The entire solar power plant is very less expensive when compared to a coal power plant. So, so the energy transition which should be happening now, this energy transition has to follow the solar power plants. Other things will be there. The solar power plants and the solar energy conservation is one thing where the energy transition can be possible. And then potential for growth and expansion. So in future, around like 2070, it is like 50 years from now, around 25% of jobs will be coming under the solar power plants and the solar energy related fields. Okay. Now around 1% or 2% of the jobs are available in this market. Now in future, 25% of the jobs will be coming under the solar power plants, because this is the place where the expansion is possible, where we have to install large number of solar panels to collect more amount of solar radiation and convert this into electrical energy. And this electrical energy can be converted and it can be used like household applications, industrial applications. We can use them to run cars, we can use them to run trucks. Any electrical application can be run with the help of this solar radiation. So this is the future of solar power plants. Because of these technological advancements, the solar power plants are the future. And thank you. We'll meet in the next class.
Like, share and subscribe. Hit the bell icon for more updates.